Thank you very much, Christoph. I appreciate this opportunity. Many of you may know Brewer Science from our history, 40 years of history in the front-end semiconductor, front-end semiconductor space. We're mainly a chemical and material supplier for the front end. And now also we've been doing a lot in packaging materials as well for the back end as well. But one sort of secret is that we've been playing in the print electronics space now for a better part of 15 or so years. We started in roughly 2006 timeframe developing CNT-based inks. So we did a lot of early research in carbon science and develops a lot of our own carbon nanotube-based, functionalized carbon nanotube-based inks. We quickly realized that that's not such a huge market, so we moved into the printing space and started developing our own printing capabilities. And in this space, not just printing carbon nanotube inks, but at that time, silver inks and other functional materials. Very quickly, we moved into sort of 2010 to 2012 timeframe into producing our own sensors and developing our own sensors around force and strain sensors, water quality sensors, gas quality, air quality sensors, humidity sensors, etc. We are not a supplier of individual components, but in the more recent years, we have moved into sort of systems integration and software where we're taking our own inks and commercial inks, printing them, developing our own sensors, our own devices, and packaging them into systems that then we develop the firmware and software for that. Started developing some AI and machine learning characteristics to do predictive analytics, for example, and data analytics, because in the end, what we discovered is what our customers really care about is the data. They don't care what the sensor looks like always. They don't care how it's made. What they really care is that the data is accurate and most importantly, in as real time as possible. So I'm going to talk a little bit about one area that is a big focus for us of late, and that is on print electronics, or trying to deploy print electronics for water quality measurements. So we have, over the last couple of years, been developing various water sensors, sort of sensors that measure water contaminants in particular. Nitrates and lead, heavy metal materials, organic content, pH, ionic conductivity, and so forth. And these are all printed devices. And some of them are CNT, functionalized CNT based, but we also, have electrochemical based sensors and other materials that we've developed over the years. So not just CNTs, but our focus right now is to try and use printed devices and use their small form factor and low cost of production, so that we can start distributing our sensors over large areas. So thousands of sensors deployed to measure the water quality of our rivers, lakes, and streams, our reservoirs, integrating it into our water treatment facilities in municipal centers, as well as measuring in the distribution systems and the spigots of industrial buildings, commercial buildings, and residential buildings and government buildings. From this, all of our sensors can be deployed in any of these applications, but we're really focusing on large distributed networks. And to do that, then we've been able to build a system that allows us to connect all of our devices and sends the data to a cloud server. There's analysis done in the cloud, and then that data then gets distilled and sent to a portal or to our customers directly. And this is now a full system that we are currently testing in our in the field. I've put up here a list of current sensor types that we have. I've highlighted nitrate and lead because these are very interesting areas for us in particular, is a large focus for us. But we can also integrate a temperature, ionic conductivity, chloride, potassium. So these are all contaminants in the water system that we think are important to measure. So with that, I'll end it there.